equivalent circuit for this given example, where across AB load will be connected. So basically in this example we have to figure out Norton's equivalent current and Norton's equivalent resistance. So for that we have to connect, or we have to short this AB terminal after replacing the load. So the actual circuit was like this, where load was connected, and what I did is I have short circuited this load so that the current flowing through this path is Norton's equivalent current. As we know that current will always follow least resistance path, so we can easily remove this because it will not have any impact. I redraw this circuit after making few arrangement, like if I shift bit this on right side, and these are the common points, so that we can easily assign node voltages. So what I have done is I have assigned two node voltages VA and VB here. Now considering VA highest as compared to VB, so I can assign I1, I2, I3 current. Similarly for VB, I4, I5 and I6 current. So at this particular node, at node VA, we can write that incoming current is equal to outgoing current using Kirchhoff's current law. So that would be I1 plus I2 plus I3 would be equal to 0. And at node B, that would be I4, I5, I6, which will be equal to 0. Now what is I1? So I1, which is current flowing like this. Now in this path we are having VA node and this 10 volt. So I1 would be VA minus 10 upon resistance is 10. Here I2 VA minus, as this is ground, so 0 volt. So VA minus 0 upon 10. And I3 is VA minus VB, because see this resistor is having 2 point, one is a VA, other is a VB, and 20 ohm resistor. That would be VA minus VB over 20, which will be equal to 0. So that is for node A. For node B, I4 would be VB minus VA upon 20 plus VB minus 0 upon 40 plus VB minus 0 upon 20. So here the factor, if you multiply and divide with 2, then at node A you can write like 2VA minus 20 plus 2VA plus VA minus VB is equal to 0. So what I have done is multiply and divide with 2. Here also multiplied and divide with 2. So in denominator 20, 20, 20, and this 20 I have kept out and multiplied with. So here this is 2VA, 2VA and VA. So that would be 5VA, then minus VB, then is equal to, if I 20 on this side, this will be 20. So that is equation number 1. Now here what we can do is multiply with 2 on first and last term, so that in denominator we will be having 40, which we can take it out and we can multiply with 0. So that would be like 2VB minus 2VA plus VB plus 2VB is equal to 0. So here that would be 5 VB. So we have to solve it. So I can take this equation. So 5 VA minus VB is equal to 20, and minus VA plus 5 VB is equal to 0. So what I can do is I can multiply this with 2 and this with 5. so that this would become 10 VA, 2 VB, 40, and that would be 10 VA, 25 VB, 0. So this will be cancelled, so that would be 23 VB is equal to 40. So VB is equal to 40 divided by 23. So 40 divided by 23 is 1.7391 volt. So 1.7391 volt. And what about if you remember, so this current, if we name it IN, that would be VB upon 20. So VB over 20 is IN. So VB is 1.7391 divided by 20. So IN would be divided by 20. So 0.0887. So 0.087 ampere. So we can consider like 87 milliampere, right? So we can cross verify this using LT Spice simulation. So the same circuit I have built using LT Spice, and I have shorted this output, and if I run it again, just look at this current which is flowing through this 20. So this is 86.96, which is very close to 87 milliampere. So what we have followed the path of solving